Okay, so we're starting our new unit. This is our physics unit, and it is called optics. I'm going to be providing you with quite a few different optical illusions to look at because they're just fun and interesting, and they trick our brain. Because one thing we're going to learn this unit is we do not see with our eyes; we see with our brain, and what we see is not always real because our brain loves to fill in the blanks and make little shortcuts for us. We're expending less energy assessing our environment, and in doing so, it opens up all these wonderful optical illusions, which are just fun. So here's one here. Just read through, and then we'll move on. So you're going to start and stop this lesson as I go so you can take down some notes, and then it's paced according to how you would like. So we're going to skip through this section because we need to vote, and we can't vote because, we just don't have time and we're not sitting in a classroom. So we need a few definitions for this unit, and we're going to start with the what is light. Light, well, how do you describe it? Well, it's hard to describe. It's not matter, right? It's energy. And energy is hard to get a description of. We can say that it travels at 300 million meters per second in a vacuum. Um, and the light from the sun takes 8 minutes and 20 seconds to reach the earth. So everything, the light that comes down to the earth, yeah, it's traveled 8 minutes and 20 seconds to get here. Note, space is a vacuum, therefore no matter in a vacuum, not even air. So light and energy. Light is energy that travels through space in the form of an electromagnetic wave. Light does not require a medium. So it is a type of energy. And that energy can be measured. So it is a range of energy. We can measure it. Light, it has dual properties, which makes it quite interesting, especially when you get into physics later in your senior level physics. But light can travel as a wave or as a photon. So photons are small little packets of light energy. We call them discrete quanta. So they're like coming down from the sun. Oh, I don't want that one. I want this one. So coming down from the sun, you can picture them as little discrete little packets of energy that bombard us. So a few properties of light when we look at it as a wave. Remember, I said it has dual properties. We can look at it as a wave. It travels as waves or as photons, little discrete packets. But we're going to look at it as a wave now. And to do that, we have to understand a little bit of terminology. So first, what is a wavelength? The distance from one place in a wave to the next. Similar place on a wave. So it doesn't matter where you measure it. So here, if we look, they're showing this from the top of the wave, right? The top of each crest. So they're measuring from one to the other. You could also do the same thing by measuring down here. It doesn't really matter what two places you pick to measure wavelength, but it has to be a similar place on the wave. So I always like to go from crest to crest. Trough to trough works too. You literally could measure any place on the wave as long as you go to the similar place on the next one. So crest to crest is considered one wavelength. Trough to trough is equal to one wavelength. And again, those are just the easier points to measure from, more obvious. And the units that we measure wavelength in is meters. Nice. Okay. It's like Monday morning today. Okay, so then we have amplitude. That is the height of a wave. And again, the wave, if we look at the height here, let's change this color. So the height the amplitude is just for one wave. Okay, so it's just from that center line up is the amplitude, that's the height. And the frequency is the rate of repetition, and it's measured in hertz. So frequency is important when you'll see when we're looking at the different types of electromagnetic radiation. Okay, so if I were to measure the frequency, the rate of repetition of the wave. So if you look at this wavelength here, okay, the rate of repetition. So this is repeating at the same frequency. But if I took a wavelength and I, made it happen at a faster frequency, it would just go crest to crest quicker. So it would just, and then, I'm not very good. It's quicker and quicker and quicker. So here I'm showing you the frequency increasing. Okay, it takes less time to go from crest to crest or trough to trough. So the frequency increases. You're going to see more wavelengths in less space. So that is showing an increase in frequency, and frequency is rather important, again, when we look at the electromagnetic spectrum, which you're going to be doing later. So, of course, we are in the physics unit, which means there's going to be a little bit of math. Not too much with regards to this. We actually spend a lot of time doing ray diagrams. So just a heads up, you will need a ruler and a protractor. So hopefully you can get those things. Stores are opening up. So you can get them at Walmart, Staples. I believe Staples open today as well. So you're going to need a ruler and a protractor and a pencil because, again, physics is a lot of math. So those are things you're going to need probably every day starting in a couple days. Okay, so the relationship between speed, frequency, and wavelength is shown in this triangle. So these triangles are rather nice to use. So, if here at the bottom of the triangle we're multiplying, and here it's divide and divide. So velocity divided by frequency is going to equal wavelength. Velocity divided by wavelength is going to equal frequency, and frequency times wavelength is going to equal velocity. So hopefully you understand how to use these triangles. Calculate the speed of a wave if the frequency is 60 hertz and the wavelength is 25 centimeters. So I just want you to try these. 2 questions. They're not hard. Just give them a try. I'll put the answers in your lesson for tomorrow. We don't spend a lot of time doing these types of calculation, but just so you know how to use that little triangle. And then attached to this lesson will be a worksheet I want you to fill out. And that's it for today.